for chapter 2 and for chapter 4. First, I want to talk to you about vector notation and magnitude and direction, and what I mean by these terms. So if I write a vector, let's say A, and that's equal to 3 in the I hat plus 4 in the j hat minus 5 in the k hat. When I'm writing it like this, and I have the little a with the arrow over it, and i's, j's, and k's, this is what we call vector notation. So if I want you to write something as a vector, this is what I'm talking about. So if I say on the exam, give your answer in expanded vector notation, I want to see it in the I hat, j hat, and k hat directions. I want to see it written out like that. Now let's say I ask you, what is the magnitude of this vector? How do you find the magnitude of a vector? Yeah, could you say?
Square root of I squared, j squared. I squared plus j squared plus k squared.
You take the square root of every single term squared. It's Pythagorean Theorem. Same thing as x squared plus y squared equals z squared. A squared plus b squared equals c squared. All the same thing. This, you're just doing it in 3 dimensions. So the magnitude of this, which we can write as an A with 2 little bars next to it, is equal to the square root of 3 in the I hat direction squared plus 4 j hat squared plus negative 5 k hat squared. So add all those up. Let's see what we got. What's 3 squared?
9.
9. What's I squared? I times I is, and I squared is 1. Okay? This is I, the unit vector direction, not I, the imaginary number. Stupid imaginary numbers. So this is 9. What's 4 j hat squared? 16. And what's the j hat squared? 1. Square a unit vector, you get 1. Unit vector. Unit means 1. So 4 times 4 is 16. So 9 plus 16 plus, what's negative 5 squared?
25.
25. Positive or negative?
Positive.
Positive. So we got magnitude of A is equal to the square root of 9 plus 16 plus 25. What's that?
50.
50. What's the square root of 50?
25 root 2. Wait, 5 root 2.
Give it to me as a decimal.
7.7.
7.1.
7.07 or 7.1. Okay? On your exam, are you going to be allowed to use calculators?
Yes.
So I want to simulate the MCAT, so no calculators. You need to be able to do that in your head. Sure. Is what an insane person would say. Use your calculator. Plug that into your calculator. Use your calculators all you want. Program things into your calculators. Square root of 50 equals 7.1. Plug it into your calculator. Make sure that you can do that. I've seen lots of people lose like 10 points because they couldn't plug in the square root into the calculator. So make sure you know how to do that in your calculators. But there you go.
Yeah.
Last thing to do, always, 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 always circle your final answers. This is good practice because it makes it easy for me to find your answers. And you want to make it as easy as possible for me to grade your exams. I have to grade 30 of your exams. It takes me about an hour to grade 1 exam. If you don't circle your answers, it takes me even longer.
That's 30 hours.
And what's that going to do to me? It's going to make me angry. It's going to make me angry when I'm grading your exam? I won't. Just try to circle your answers. Okay. Any questions on that? So that's vector notation. Is doing the i's, j's, and k's. Find the magnitude of it. Square root of the sum of the squares. Let's say I'm given a vector b. And I say this vector b is 5 in the I hat direction minus 4 in the j hat direction. I tell you to find the magnitude and the direction. First, how do I find the magnitude? Square root of the sum of the squares. So I have my b vector magnitude is going to be the square root of 5 I hat quantity squared plus negative 4 j hat quantity squared magnitude is b. Magnitude of b is square root of 5 times 5 is 25, plus 4 times 4 is 16. So square root of, what is that, 41. And square root of 41 is, you said 64? 6.4? Square root of 41, 6.4. So I plug that in, I get my magnitude. How do I find the direction of this?
Go back to where you look.
Say it louder. Draw a diagram, draw the coordinate system. So let's draw a coordinate system. And then let's write out where we're going. I've got 5 in the I-hat direction. So as long as you're doing the normal coordinate system, I assume you're all going to just draw a normal coordinate system where anything that's going to the right is positive. I would go over 5, and then where would I go? I would go down 4, negative 4 j hat. Okay, over 5. Let's go over 5 to right here-ish. Sure. And then let's go down 4-ish. Sure. Draw it approximately to scale. And then the resultant vector is my green vector. How long is that green vector? 6.4. We just found that. 6.4. How do I denote the direction of this vector? I made a picture, but I want more than that. What if I want a number related to the direction? Find the angle. What? There's a bunch of angles there. What angle do I draw?
Between the vector and the x-axis.
I draw between the x-axis and down to the vector. So that angle right in there. So let's draw that angle in. What kind of triangle did we draw? Right triangle. Do we have trigonometry that relates to a right triangle? Yeah, all those trig functions. They'll never go away. Which trig function can I use here? I can use sine. Can I use cosine?
Yes.
I can use cosine. Can I use tangent?
Yes.
Yes, I can use tangent. Let's use tangent. So I'm going to do tangent of theta. What would that be equal to? I need the opposite over the adjacent. 4 over 5. Okay. And then this is another one that you probably want to plug into your calculator. This is pretty straightforward math, but can be tricky if you haven't done your calculations in a long time. So if I want to find what theta is, I need to take the inverse tangent of both sides of this. So I take the inverse tangent of both sides. Inverse tangent of tangent gives me just theta. Then I need to do the inverse tangent of 4 divided by 5. Plug that in. Get your answer. Plug that in. Make sure that you're getting 38.7 degrees. If you are not getting about 38.7, 39 degrees, then you're probably in radians. Make sure your calculator is giving that as your answer. This whole exam, you can be in degrees. You don't need any radians. Okay, any questions on that? So that is a complete answer to what is the magnitude and direction of this vector. What if I gave you a 3-dimensional vector? How do you show the direction of a 3-dimensional vector? Guesses? 3D vector? Any guesses?
Would you have to give multiple angles from?
You'd have to give multiple angles. That'd be a pain in the butt. I don't want to grade that. You don't want to do it, so you won't get magnitude and direction in 3 dimensions. You'll only get magnitude in 3 dimensions. Okay? Magnitude and direction in 3 dimensions we'll do in the engineering class. Yes, ma'am. So you could say below the x-axis if you didn't draw this picture. But if you draw a picture, I can see that you know what this means, that this is the right direction. Because whether you realize it or not, that's the purpose of the exam. I'm not doing it to be mean. I'm doing it to see what you understand and what you know. And this shows me that you know what direction this vector is going. This picture shows me a lot. Okay, So as long as you give me something that tells me that you know stuff, then you get partial credit. Yes, ma'am.
So, the J hat is negative 4, but when you draw the picture, the negatives will be and then go down to the actual number of the calculates for positive.
Yeah. As long as you draw the picture. If you plugged in a -4, then I believe you'd get like a -38.7, so that would show you that it's negative. I prefer just plug in positives for all the numbers and draw a picture. Much easier. Okay. Any other questions on that? Yeah. And K, yeah. What if I gave you something that looked like this? What if I gave you a different vector? What if I said it was shit? How do I do I know how to do 5 in the I hat direction, but how do I draw a -4 K hat?
You still square.
It's the I hat. And I can say that's K hat. Same exact thing. Same exact approach. I just changed the name of the axis. I direction and K direction. What if I made this J hat and K hat? I would just change I to J. Same math, same concept, same exact problem. Solve it the same way, all your numbers come out the same. Just change 2 little letters. Okay. And that's the kind of sneaky stuff I do. Change a couple letters. That's the same problem, same approach. Any other questions on this? Five J hat. If I did 5J hat minus 4K hat, the picture still looks the same. You just make the I axis the J axis and the J axis the K axis. Right. And then the other thing we want to do an example of the hardest kind of projectile problem I might give you.
Yay.
It's the absolute hardest that you would get.
Stay where you're gonna get there.
And I'll show you an approach that'll work for it every time. Okay, so this is problem number 95 in chapter 4. You're going to be shocked that I picked this problem. A mountain biker encounters a jump on a race course that sends him into the air at 60 degrees to the horizontal. If he lands at a horizontal distance of 45 meters and 20 meters below his launch point, what is his initial speed? We need to find out what's the initial velocity of this guy that flies off of this jump and lands below where he started. How do we do this? What's the first step of any physics problem? Draw a picture. Let's draw what this looks like. So I have this mountain biker comes along, he hits a jump, he goes, he flies up in the air, and he's going to come back down, and he's going to land below where he started. So I'm going to kind of draw, let's draw ground. Ground is green, and he's going to actually, the ground isn't complete. He's not going to burrow into the ground. So let's imagine he's kind of riding his bike off of a cliff because he's stupid. Anybody mountain bike? No? Okay, so mountain bikers, they're really stupid. They do this kind of stuff. They ride their bikes off of cliffs. I don't understand it. Okay. For adrenaline, I don't know, to injure themselves, lose a limb so that I have people to make limbs for, whatever.
Keep me in business.
Yep. So, bike goes, jumps off of this ramp, goes flying, transports some distance x, and lands below where he started. So I can write in some things that I was given here in this picture. I know a mountain biker encounters a jump on a race course, sends him into there 60 degrees to the horizontal. So I know that this angle right here is 60 degrees. Great. If he lands at a horizontal distance of 45 meters and 20 meters below his launch point, what is his initial speed? Bless you. So we've gone a horizontal distance. That's the x. Horizontal distance was 45.0 meters. And he landed 20 meters below his launch point. So if I'm launched here, my 20 meters below, change in y is equal to, what is change in y equal to? If I have gone 20 meters below where I started,
20.
it's minus 20. And then it's baked into all of the physics that this guy can go flying up, flying back down, hit the normal height that he launched at, and then keep going down negative 20. So if we plug in that negative 20, all the physics will work out. We don't have to do anything special, just all the equations will work. This is kinematic motion in 2 dimensions, but kinematic motion in 2D is the exact same as kinematic motion in 1D. So the next thing that you want to do for all problems that you're given, if you're completely lost, draw the picture and then write out everything you know and write out all of your equations. So let's write out all the equations that relate to kinematic motion. V final equals V initial plus A times change in time. Change in x equals V initial times change in t plus 1/2 A times change in t squared. And then Vf squared equals V initial squared plus 2 times A times change in x. These are all the kinematic equations of motion that describe how things move when you have constant acceleration. Anytime you have a projectile, this is what you do. And then the approach that I told you in 1 dimension. What did I tell you to do for 1 dimension motion problems? Right? Write out this little table. Write that table, this problem as well, but you want to do it in the x direction and in the y direction. Write out that little table and fill it in. So for the x direction, change in x, V initial in the x direction, V final in the x direction, A in the x direction, and change in time. Do I know any of these? Do I know the change in x?
Yes.
Yeah, what is that?
45.
45. Do I know the V initial in the x direction? Well, I'm launching, I'm flying off of this. If it was 0, I would just be stopped. So I am moving forward at some velocity. Let's call it V initial. That's actually what we're looking for. But what's V initial in the x portion of that? I'm going off at an angle.
60.
So what kind of shape do I have here? It's a right triangle, right? I've got initial in the x direction. And I have V initial in the y direction. That's a right triangle. So what side of the right triangle is V initial x? Is it the adjacent side or the opposite side?
Adjacent.
It's the adjacent side. Which trig function is adjacent?
Close.
Cosine. So this V naught x, I don't know exactly what it is, but I do know it's V naught times the cosine of the angle. What's the angle?
60.
60. Can you solve what cosine of 60 is? You plug that into your calculator. What's cosine of 60? 0.5. So this is going to be 0.5 times V0. So I don't know everything, but I do know it's half of the initial velocity. That's useful. Okay, V final in the x direction. What's that? Do you remember for projectiles what you can say about V initial, V final, and A? They're the same. Because what is A in the x direction for a projectile? 0. Acceleration is a change in velocity. So if the change in velocity is 0, that means the final velocity has to be the same as the initial velocity. So final velocity in the x direction has to be 0.5 times v0. So when I have a projectile and it's moving in the x direction, in this physics class, we can assume there's no air resistance. We can assume it's not accelerating at all in the x direction. So ax is equal to 0. Acceleration is the change in velocity. So the change in velocity has to be 0. Change in velocity is final velocity minus initial velocity. For that to be 0, these two have to be the same. So 0.5 v naught. In x direction, they are always the same unless something in your problem suggests that they're not. There can be situations where they say assume there's air resistance or some other force that's changing the x acceleration. Generally, we assume that's it. We're pretty safe doing that in our intro physics class. Okay, change in time. Do I know how long this mountain biker's jump takes? Did they tell us in the problem? No, they didn't tell us anything about that. So that just stays change in t. And then I can make the same exact chart in the y direction. Change in y. Do I know what change in y is? What's that? Negative 20. Negative 20 meters. V initial in the y direction, do I know what that is?
Zero.
V initial in the y direction.
0.
Not 0. Because he is moving in the y direction. It's going to be the sine of the angle. So V initial times sine of 60. Plug in sine of 60, and you should get about 0.87. So V initial y is 0.87 times V naught. V final in the y direction, do I know what that is? I don't know what that is. Acceleration in the y direction, what's that?
G.
Negative 9.8. Gravity's pulling you down, causing an acceleration downwards of 9.8 meters per second squared. Change in time. Do I know what that is? No. Okay. All of this stuff. This is just setting up the problem. Okay? Without knowing any physics at all, considering that you could write all of those on your cheat sheet, without really doing any solving, any calculating, with the exception of plugging that into your calculator, this gets you about a half credit. So if you can do this, you should be able to get half credit on this problem. Okay? Now the hard part comes where you have to start plugging it into equations, figuring out what to solve and how to solve it. Okay, what would I do? What do I start doing? These kinds of problems, I like to look at the x direction and the y direction and maybe try to solve one of the directions. Right? If I look at these, I see there's a v0 in both of them, and there's a t in both of them. Those are the same. So if I can find one of the variables, I can plug it into the other one. Okay. All right, what can I do? What direction should I start with? Should I start with looking at things in the x direction or the y direction? What do you think?
In the x direction,
Why?
because you have the most variables there that you do know.
You have the most things that you know in the x direction, so let me see what I can solve in the x direction. Yep. So I take these equations and I start looking at them. Do I want to use, what can I use the first equation?
No.
Well, so what happens if I do use the first equation? If I plug in Vf is 0.5 V naught equals V initial. V initial is 0.5 V naught. Oh, good. plus acceleration. What's acceleration? 0. So 0 times t, that goes away, and I prove Vf equals V0, which we already know. Unless you forget that, you would end up solving it. Okay, so first equation, didn't do anything. Just made us more confident in what we do. Let's look at the second equation. Second equation. Let's skip the second equation. Let's go to the third equation. Let's look at the third equation. Vf squared, okay, so I square this, equals V initial squared, plus 2 times A. What's A? 0. So that goes away. So I prove Vf squared equals V squared. I can take the square root of both sides, and I just proved again Vf equals V0. I just did the same exact thing. That's why these problems can take some time. So you might try an equation, and you might just prove V equals V. Oh well. Go to the next equation, try that one. And then if that one doesn't give you anything useful, try the last one. So let's try that last one. Change in x. Oh, this looks like it's going to get complicated, though. Change in x equals V naught x times change in t plus 1/2 times ax times change in t squared. I can plug in some numbers, can't I? What can I plug in for change in x? 45. V naught x, what can I plug in for that?
45 V naught.
I can plug in 0.5 times V naught times change in time plus 1/2 times ax. What's ax? 0 times change in t squared. So what happens to that second part of the equation? That goes away because you're multiplying it by 0. So now I know that 45 equals 0.5 times V naught times change in t. I can get one of those variables by itself. Which one do I want to get by itself? V naught or t? Which one should I solve for? T? Why t? Same t over here as I have over here. So let's solve this for t. Okay? In general, when you're doing these problems, it's a good idea to find t because t is always the same between x and y in general. V0 might not always be, so you want to solve for change in t. Okay, so let's solve for change in t. Get change in t by itself. I divide both sides by 0.5 times V0. Divided by 0.5 times V0. So we cancel that out on the right-hand side, and I see the change in time is equal to 45 divided by 0.5 times V0. What's 45 divided by 1/2? 90. So I know change in t is equal to 90 divided by V0. So I did 45 divided by 0.5. Put that in your calculator, and you will get 90. Still have the V naught on the bottom. So I know what change in time is in terms of V naught. So I can use that in the y direction. Let's look at the y direction. What things do I know in the y direction? I know change in y. I know v initial y. I don't know v final y. I know ay. I know change in t now is equal to t, which is equal to 90 divided by v naught. So the one thing that I don't know, there's a couple things I don't know. I don't know what V0 is. I know V initial y is equal to 0.87 times V0, and I don't know what V final y is. So I don't know either of the velocities. So look at your equations again and try and figure out which one we should use. Do I want to use the first one? Is that the first one I would pick to use? Vf equals V0 plus A times t. I don't know either velocity. So I might skip that one for now. Last equation, I also need both velocities. So I might skip that one and look at the middle one. Middle one, all I need is the initial velocity. So I would experiment and see what I can get out of that second equation. Second equation, oh wait, that says change in x. And we're in the y direction. Can I use it?
Change in y.
Yeah, these are interchangeable. X can be y. So it's a change in position. So we can equally validly write this as change in y equals v naught times change in t plus 1/2 a times change in t squared. This works fine. So let's do that. Change in y equals v initial in the y direction times change in t plus 1/2 a times change in t squared. Ooh. This looks messy. I got squares in there. When I was in your seats, when I took college and university physics, I would freak out when I saw something like that because it reminded me of this thing I did in high school called, remember the Quadratic Formula? Mm-hmm. Oh yeah. Ugh. Anybody remember the Quadratic Formula? It's like negative b plus or minus square root of b squared minus 4ac all over 2a. Oh God, are we going to have to do that? I hope not. We can. Let's see. Let's see if we need to. Change in x. What is change in x? Negative 20.
Change it.
Or sorry, change in y. That's what we want. We want change in y. Negative 20. Do as I don't say. Read my mind. Negative 20. That's the change in y. V initial y. What is that equal to? 0.87 times v initial. What's change in t?
90 over V naught.
Is 90 divided by v naught. Plus 1/2 times a. What's a? Negative 9.8 times change in t squared. Change in t squared is 90 divided by v naught, quantity squared. So I've just drawn a big equation. How many variables are in this equation? How many unknowns are there in here? One unknown. What am I looking for?
V naught.
V naught. So you've got, if you get it to this equation, you're 90% of the way there. So this would probably get you like 8 or 9 out of 10. So now we just got to get the rest of the way. We got to do the algebra there. So let's do some algebra. The V naughts are going to cancel out over there. I'm going to have negative 20 equals 0.87 times 90. What's that? 78.3. And then I need to do 1/2 times negative 9.8 times 90 squared. $39,609. And make sure you don't forget that negative. So that's that, all of that numerator squared, and then V naught squared on the bottom. Where do I go from here? What am I solving for? I want to get V naught by itself. So to do that, I need to make sure that there's no adding or subtracting or anything in my equations. So I need to get everything isolated. So I'm going to subtract negative 78.3 from both sides. So I do that subtraction, and that gets rid of 78.3 on the right. Negative 20 minus 78.3. What does that give me?
Negative 98.3.
Negative 98.3 equals negative 39,690 over V naught squared. I'm going to get rid of fractions because fractions are the bane of my existence and I despise them. Multiply both sides by V naught squared. Cancels it out on the right-hand side. I get negative 98.3 times V naught squared equals negative 39,690. Divide by negative 98.3. you get 403.8. And then what do I do?
Square root.
Square root of both sides. And I get V naught is equal to 20.1. What are the units on that? Meters per second. How do I know that?
That's just velocity.
Because it's a velocity. So there we go. That is the most involved problem you would get on the exam. Okay. Any questions on that?
And then next year, this
If you were asked to find V final for y, you could. You were asked to find what's the initial velocity. So that's it. This is number 95.
So we don't put the negatives in?
That negative cancels with that negative. Any other questions? Questions? Okay. I'll stop this recording.